Graphing linear equations comes down to a couple of things. It comes down to plotting points and recognizing slope. All right, we can always use points to plot any equation ever, and that's not just lines. We can always set up X, Y charts. That kind of stuff is kind of a fallback, but lines have a lot of special things about them that allow us to graph them much faster. One of those things is the slope. And so the slope, remember our slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We basically subtract the y values over subtract the x values. You just have to make sure you subtract the y values and the x values in the same order based on the ordered pairs, okay? We could also look at it as change in y over change in x. This is just a mental math approach to this formula. We can also think of it more broadly in terms of change in y over change in x. When we look at like an xy chart, a lot of times we'll think about it in terms of the pattern of how is x changing, how is y changing, and then putting those things over one another. And then this last one, this is kind of the one we use when we're talking about graphs. When we look at a graph, we talk about it as rise over run. Okay? As I go from one point to the next on the graph, how far up do I have to go and how far over do I have to go? That is my slope. Okay? And so looking at these guys, if I want to identify the slope of each of these, and again, these are two separate examples. If I look at the first one here, change in y over change in x, or using my formula, so I'll do the formula here first. I'll say, okay, the second y value, and really just label these. Say, hey, you know what? This is my first and x and y value. Here's my second x and y value. And so now as I plug this in, I would just say, okay, this is going to be the 4 minus the negative 5, and be careful with the signs there. Then over the x values, that's negative 2 minus the 4. And again, it's important that we're consistent. Since I started with this y value in the numerator, I have to start with this x value in the denominator. Okay? As long as I'm consistent, I do those in the same order. Now up here, subtracting negative is like adding the opposite. So that gives me a 9. Down here, subtraction is like adding the opposite. So that gives me a negative 6. And now I reduce this fraction, so that's a negative 3 over 2. Okay, so that's my slope on this one. Okay? If I do change y over change in x, it's the same thing. I'm looking at this saying, hey, let's do change in y first. So y was a negative 5, now it's a positive 4. If you think about that on a number line, it means that's gone up 9 units, and that's where I get this positive 9 right here, okay? If I look at the x's, it was a 4, now it's a negative 2. It's gone down 6 units, that's a negative 6 in the denominator, okay? And so we literally get the same thing that we get when we do the subtraction. We just kind of cut out that first step. We convert it to mental math, all right? If I look at the next one, rise over run, I just look for points that this thing goes through. It looks like it goes through this point, and this one, and this one, and this guy here. And so we just go from one point to the next, and I just count up and over. I just say, hey, to get from this point to the next point, I have to count up 3 and over 2. And then to get from the next one to the next one, it's up 3 and over 2. And to get from the next point to the next point, that's up 3 over 2. And what I'm describing there is rise over run. I'm saying the slope is up 3 and over 2, so that's the rise over run. That's the slope, okay? And when you compare these two things, these are two separate examples. The first one, remember, a negative slope, if I were to graph these ordered pairs over here, the negative slope would give me a line that kind of trends downward like this. And so be aware of positive versus negative slope in terms of what it looks like on the graph. The first format we have for graphing equations is standard form. That's when the x and the y are on the same side. And the best way to graph when it's in standard form is to do the intercepts. Remember, we can find the x-intercept by plugging a 0 in for y. So in this format, if I plug a 0 in for y right here, and then I can solve for x just by dividing, okay? Then to find the y-intercept, I plug a 0 in for x. If I plug a 0 in here, I can solve for y just by dividing, okay? And so what I do then is I plot those 2 points. Well, once I have 2 points, I'll have the slope, I'll have the rise over run, and I can continue to plot more points after that, okay? For example, if I look at this guy, again, I want to do the x and the y intercepts, and so I just plug in a 0 for y. If I plug in a 0 for y, if I just had this equation, and most people can solve this through mental math, you could say, hey, the x value here is going to be a 4. And that's when I plugged a 0 in for y. So it's the ordered pair for 0. Again, we're just solving for x right here by dividing each side by 3. Okay? And then we'd say, hey, let's do the same thing with the y value. Let me scribble this out. Let me plug a 0 in for x. Okay? And if I plug a 0 in for x here, well, if I solve this, I could use some mental math or take it off to the side and say, hey, let's divide each side by -4. And I end up with y equals a -3. So over here, that's the y-intercept is -3. And again, write them as ordered pairs. It's always a good idea to write them as ordered pairs because it makes it a little bit easier to make sure I don't make a mistake when I graph it. So now I plot each of these. 4, 0 is right here. 0, -3 is down here. And now I could continue to plot points. Look at this, rise over run. To get from one point to the next, I would go up 3 and over 4. So I could continue to go up 3 and over 4 and get another point. Or I could go the other way. I could go down 3, back 4. And so down here, down 3, back 4. So I can continue to plot points even after those initial 2 to make this line a little bit easier to graph. And that's it. If I look at the next one, same kind of thing. I want to plug a 0 in for each. And so here, I might start by plugging a 0 in for x this time. Okay? And so when I look at that in terms of an ordered pair, a 0 for x. And now if I solve this for y, divide each side by 2, you get y equals a 2. That's this value in my ordered pair. Okay? And now I plug a 0 in for y. Let me scribble this guy out. So I plug a 0 in for y. So I have negative x equals 4. I would have to divide each side by a -1. And I would get a -4 for my x value. So that's -4 for x. And that's when I plugged a 0 in for y when I scribbled out y. Okay? And so now I plot each of these points. So I plot them. 0, 2. It's up here. I guess I was using green in the other one. I'll use green in this one. Yeah, green. Sounds great. And then -4, 0 is right here. But now I could continue to plot more points. Look at this. The rise is up 2 over 4. So up 2 over 4. And I could keep that going. I could also look at that if I reduced that slope up 2 over 4 is actually up 1 over 2. I could plot more points in between, but this should be plenty in terms of graphing. Okay? That's it. So again, we find the intercepts. Plug a 0 in for y and solve for x to get the x-intercept. Plug a 0 in for x and solve for y to get the y-intercept. And then I just plot those 2 points. And if I have 2 points, I can count the slope. I can continue to plot more points in order to graph these things. The next format we have for graphing lines is point-slope form. And really the difference here is we're going to use the slope to graph most of our points. Okay, we're going to start with a single point and then use the slope to graph more points. Unlike the previous examples where we started with 2 points and that kind of gave us the slope, now the equation will give us the slope. And so point-slope form is when we have y minus the y value equals m times x minus the x value. And that subtraction, that represents the x and the y value for the ordered pair that we're going to start at. Okay? So we're going to start at a specific ordered pair, and that's identified in the equation based on what's being subtracted. And notice, whenever you have subtraction, it's almost like whatever you see here, you'll do the opposite of that. So if you think of this as an opposite sign, the ordered pair is the opposite of this guy, which is just the y, and then the opposite of this guy, which is just the positive version of x. Okay? So think of it like the opposite construct your ordered pair. And then the value out front here, this guy, that's just the slope. So we'll use that in terms of rise over run to count to the next point. Okay? So if we look at this guy, again, take a look at what's here and say, all right, this guy right here, if I do the opposite of that, instead of a -2, I'm going to say +2. So that's the +2 for the x value. And this guy, the opposite of this thing is a +1. So that's my ordered pair, 2, 1. And one of the things the students sometimes get mixed up is they're like, well, which one's x and which one's y? Well, the x is the one that's written over here with x, and the y is the one that's written over here with y. So just keep that in mind. And now the slope on this one, well, the slope is 2 over 3. So that's my rise over run. So I start at the ordered pair 2, 0. Or sorry, 2, 1. So 2, 1 right here. That's my first ordered pair. And now the slope is 2 over 3. That's rise over run, so up 2. So I count up 2 and over 3. And then I count up 2 and over 3 again. And if I continue this pattern, go the other way, if I went the other way, I'd have to go down 2, back 3. Down 2, back 3. And I could continue the pattern the other way, down 2, back 3. down 2, back 3, down 2, back 3. And I could do this as many times as I need to or want to in order to help me graph a nice line here. Okay? Really, I only need 2 points, but the more points, the kind of the merrier here, and it'll allow us to draw a little bit of a nicer line. Okay? Again, the next one, I look at x, and I say, okay, the opposite of the value with x, so I see a minus 3, so I'm going to put a plus 3. So the ordered pair is going to be 3, comma. Now I go over to y. The y value here is a plus 2, so I'm going to do a minus 2, and that's my ordered pair. Okay? And now the slope of this one is a negative 2. And anytime I have a whole number or an integer or something like this for m, for the slope, I can always just put it over 1 in order to count my rise over run. Okay? So I start at 3, negative 2, so 3, negative 2 is down here. And now a slope of negative 2, that's down 2 over 1. So down 2 over 1. And that's what the negative indicates. It just indicates, hey, let's go down and then over, because I want this downward sloping line. And so I kind of ran out of points here. Well, if I wanted to go the other way, it would be back 1, up 2, or up 2, back 1, up 2, back 1. And so I could continue the pattern going the other way if I wanted to plot some more points. And there it is. Okay? The last format we have for graphing lines is we approach this in terms of the graph. We approach it doing the exact same thing that we did for point-slope form. Okay? The only difference is that the specific point that's given is the y-intercept this time. Okay? So slope-intercept form, graphing is the same as it was in the previous examples, except instead of starting at any ordered pair and using the slope, we're starting at a very specific ordered pair and using the slope, and that ordered pair is the y-intercept each time. Okay? And so in this format, it's y equals mx plus b, m is the slope, b is that y-intercept. And so what I do here is I say, hey, the slope, well, that's going to give me the rise over run. That's going to tell me how to count from one point to the next, just like it always has. But the y-intercept will now be my starting point. Okay? And so when you think of this, think of it again as the ordered pair. It's 0, comma, b. And notice there's no opposite sign here. It's a plus sign. So whatever we see there, that's what we take. It's not like a point slope where we have to do the opposite of the value we see. We take the exact value we see. And so if I look at something like this guy, again, if I wanted to talk about the y-intercept, we talk about this guy exactly what it is. It's a plus 1. It's a positive 1, so the y-intercept is a 1. And again, as an ordered pair, that's 0, 1, if that helps. Okay? It's a 1 on our y-axis. The slope this time is a negative 2, and again, I can put that over 1. And so now I plot the 0, 1, I plot the y-intercept of 1, and now a negative 2 over 1 is down 2 over 1, down 2 over 1, down 2 over 1. And again, I can plot as many points as I need to here. I can go backwards and say up 2, back 1, up 2, back 1 if I want to plot some more points. Okay? This next one, once again, we take this guy exactly the way it's written. So right here, I see a negative 3, so my y-intercept is a negative 3. Okay? In point slope, we do the opposite of what's there, but in slope-intercept, we take it exactly as it is. So negative 3 is the y-intercept. Again, if I write it as an ordered pair, it's 0, negative 3. And now the slope is 3 over 4. And so I start at the y-intercept as negative 3 on the y-axis. So the ordered pair is 0, negative 3. And now the slope is rise over run. It's saying up 3, so I count up 3 and over 4. And it drops me off here. And then if I count up 3 over 4 again, it gets me to here. And if I go backwards, it's down 3, back 4. Down 3, back 4, which brings me to here. And so I just continue that pattern, and now draw my line. Okay? So again, graphing lines. It starts with points. When we're in standard form, use the x and the y-intercepts. Use those points. Okay? When we're in point slope, identify the point, and then use the slope to get from one point to the next. When it's in slope-intercept form, start with the y-intercept as your point, and then use the slope to graph from there. Okay? And if all else fails, you can always, always, always do an x-y chart in order to graph these things. Okay? Plug in a bunch of x values, see what you get for y, and then plot all those points, and you should be able to still graph this line. Okay?